As promised, I wanted to include a quick video about how to do some of these problems. And please know that you can reach out to me at any point in time. I am expecting there to be some questions and some need for a little bit of extra help. So I'll go through these, and what I would ask is that if you know how to do this or you want to try it, pause it, skip this problem, or go to it only after you've tried it. If you're waiting for me to do every problem for you without trying it, it makes it a little bit harder to really understand what's going on. So in the first one, you have something outside of the parentheses that needs to get distributed inside the parentheses. So we call that distributive property of multiplication over addition, or commonly referred to as the distributive property. So we would take negative 4a times 3a and negative 4a times negative 6. So my times symbol isn't showing up very well. When we're doing this, we have to keep in mind that we have an a here and an a here. When we're multiplying them together, we would end up getting negative 12a, and then because there are two a's being multiplied together, it'd be a squared. Just like if I were to say, what is 9 times 9? You would hopefully tell me 81, or 9 squared is 81. So something similar is happening here with a times a. We have a squared. On the other side of this, we have negative 4a times negative 6. So negative 4 times negative 6 is positive 24, and the a comes down. Now, the question came up earlier today about, can I combine these two? And you cannot, because you have a squared and you have an a. Those are considered two different orders of terms. So just something to think about as you're going through this. That would be the simplified solution for number 1. For number 2, you have x1 and y1, x2 and y2. And the reason you have that is because every coordinate pair can be written as x, y. And the only reason why I'm making it a 1 versus anything else is just to say that this is the first point or this is the second point on the line that I'm trying to find the slope for. So on the blue sheet that you have something called delta y over delta x, which is the change of the y value over the change of the x value. And you can do this either way. You just want to make sure that you keep it consistent. I'm going to say that negative 16 minus 12 over negative 11 minus 3 is how I'm going to set this up. So I took y2 minus y1 over x2 minus x1. So if you notice up here, I've already identified my x1 and my y1, my x2 and my y2. I'll take the y2 minus y1 over x2 minus x1. I'm trying to find the distance between those 2 points. And when I subtract these out, I should get negative 28 over negative, oh, sorry, I made a mistake. So right here, I have negative 3. It should be negative 11 minus negative 3, which would end up being a plus. When you take a negative times a negative, it is a positive. So negative 11 plus 3 gives me negative 8. Negative 28 over negative 8 could be a solution, but I want to try to simplify this as much as possible. So I'm actually going to divide both of these by negative 4, and they would simplify to positive 7 over 2. I would accept both of these as a solution for the slope of line AB. For number 3, we have 3x, and we're going to distribute it in, just like we did for number 1. So it's going to be very similar to number 1. 3x times 8x plus 3x times plus 3 would give me 24x, and just like in that first problem, how we took a times a and got a squared, x times x is x squared. And 3x times positive 3 gives me 9x. And on the other side, I will take the minus 4 and distribute that in to the parentheses as well. So I would have negative 4 times 8x and negative 4 times a positive 3. Negative 4 times 8x is negative 32x. Negative 4 times positive 3 is negative 12. And what we'll notice now is, whereas in the first problem we couldn't do this, we couldn't combine like terms because we didn't have like terms, but in this problem we do. We can see that the 9x and the minus 32x both have the same variable with the same degree. It's both an x and an x. So I can write down 24x squared plus 9 minus 32 gives me minus 23x, and minus 12 holds by itself. This would be the simplified version for number 3. For number 4, as I mentioned in class, draw a diagram. You know that you have a 70-foot width and 10-foot length pen. You need to find the perimeter and the area of this rectangle. And we would note that by saying P equals and A equals. The perimeter is going to be all of the sides added up. So even though I don't have a number on the top part of my rectangle, I know that it has the same length as, or width, as the side opposite. A rectangle will have congruent sides. So I know that this side is also 70 feet. Similarly, I know that the opposite side of the 10-foot mark is also 10 feet. So when I take and I add all 4 of those numbers up, I should get 160 feet is the perimeter. For the area, we're going to be taking length times width. So when we multiply this out, you should take 70 times 10 and get 700. Now, the difference here in the units is that there are squared units. Okay, when we're talking about area, we're talking about squared units. And this is what we would have for our solution for number 4. Number 5 packs 3 problems into one. So the main problem we're working on is d equals t squared. What we're going to try to do is we're going to say, what happens when t is 0? So d of 0, this is saying that when our variable is 0, what is the value of d? Well, we take it and we plug it in. 0 squared is the same as 0 times 0, which gives me a total of 0. So that one's pretty straightforward. Things get a little bit more complicated when you take d of 3, because now we're trying to plug 3 squared in, and 3 times 3 should give me 9. And finally, for this one, you have d of 5, give you 5 squared. 5 times 5 gives you 25. So that's all we're looking for there. We're looking for a way to plug something in and get a value back in return. The last one on our list is a similar problem. The parts are switched, and we're going to be messing with this a lot during this module and throughout the year, so it's really important that we get this nailed down. In here, so we're going to work off of d equals 2 to the t power now. So we have d of 0 equals 2 to the 0 power, and something that we're going to talk about later is anything to the 0 power. If you plug it into a calculator, you will get that it equals 1. And we'll talk about why that is a little bit later on. Plug it into a calculator just to check and make sure. 2 to the 3rd power is the same as 2 times 2 times 2, which is 8. And d of 5, let me get a different color here. D of 5 gives me 2 to the 5th, which is, you guessed it, 2 times 2 times 2 times 2 times 2. This one here, it's important to figure out where you're at with things, so I like to go and bunch them up. 4 times 4 times 2, so 16 times 2 would give me 32. So that's all of them. Hopefully that helps. And again, if you have any questions about any of these, please reach out. I will do my best to support you. Have a great day.